In this video, you're going to learn all about negative exponents. And so we have some learning objectives. One, you're going to learn about the meaning of a negative exponent. And two, you're going to learn about the relationship between negative and positive exponents. And in the end, you're going to see how 2 to the negative third power is the same thing as 1 over 2 to the positive third power. Now, we have a whole bunch of bases and a whole bunch of exponents. And I want to show you that the 2 is called a base, and that little 3 is called the exponent. And what that means is 2 times 2 times 2. Well, that is not 6, it's 8. Because 2 times 2 is 4, times 2 is 8. But I'm going to introduce this idea also. That 1, what changed is this right here. Now, I can multiply by 1, it didn't change anything. It's still 8. It's 2 times 2 times 2. But I think that it helps illustrate what's happening with these exponents. 2 to the second is 4. 2 to the first is 2. And that exponent tells me how many 2's I have, multiplied by 1. So the 0 then means I have 0 2's, but I still have a 1. And so 2 to the negative first power. Well, 2 to the negative first is the opposite of 2 to the first. Instead of 1 times 2, it's going to be 1 divided by 2, which we write as 1/2. And 2 to the negative second power is the opposite of 2 to the positive second power. So it's 1 divided by 2 divided by 2, which is 1/4. And 2 to the negative third is divided by 2 3 times, and that is 1/8. Also, what I want to illustrate here is each time, because the base is 2, I can express this as dividing by 2 each time. That's divided by 2, and certainly that's divided by 2 each time that pattern has developed. And so what we can see also, if I erase all this other stuff here, is this pattern of positive exponents and negative exponents. What we can see pretty clearly now is 2 to the third and 2 to the negative third, 2 to the fourth, 2 to the second, 2 to the negative second, 2 to the first, and 2 to the negative first. There's a relationship there. And I want to explore that relationship. And so we have this pattern. 2 to the third is 8. 2 to the negative third, shown from the previous slide, is 1 over 8. But instead of expressing this as 1 over 8, I could use this statement right here. Well, if 8 is 2 to the third, 2 to the negative third is 1 over 2 to the positive third. And there's the relationship from the opening slide. But I want to think about this again and see that 2 to the negative third power, well, that's the same thing as 2 to the negative third over 1. You can divide by 1, same thing. But I also see this as flipping the fraction over. And as I flip the fraction over, as this whole thing gets flipped or flipped or inverted, it's the math term for flipping this over. As a fraction is inverted, the sign on the exponent is changing. And so we have this statement. Any base taken to any negative exponent, if you flip it over, the sign on the exponent changes. Pattern in play. So taking this statement, this bold statement, we can apply it to any base with any negative exponent. 7 to the negative second power is 1 over 7 to the positive second power. 9 to the negative eighth is 1 over 9 to the positive eighth. And we can even make the numbers go crazy. 45 to the negative 22nd power is the same as 1 over 45 to the positive 22nd power. And there is the relationship between negative and positive exponents explained.